My name is Hemant Chaudhary, and as part of the project, what I have done is basically I moved the file from snapshot to S3, and from there I have created a couple of Lambda functions. First is basically which read all the GIF files and invoke the parallel Lambda functions, which each Lambda will basically clean up one GIF file and clean it up and store it into the S3 back as just normal CSV format, and that way we efficiently able to clean up the files in basically few hundred seconds over there. As part of the cluster, I have created 3 node clusters as in the EMR cluster using AWS EMR, and I applied a bunch of stuff upfront to save some time for demo. And as part of the first step, I moved the S3 data to the SDFS, and I run the bunch of other MapReduce commands for the each queries and each questions we're going to solve over here. And I'm going to show the output of the each MapReduce over here to you guys. So for the group 1, I have solved the question number 1 and 2, and in the question basically where we need to get the top 10 popular airport, I already run the MapReduce command as you see over here, and the final output is going to show. I'm going to show in the SDFS, and same thing for the 1.2 where we get the basically the top 10 carriers based upon the least arrival time. So let's look into the first the output of the first top 10 airports based upon the number of the flights. You see this is the output of that one, and the output of the basically the best carriers based upon their top 10 best carrier on their arrival time, and the output is going to look like this. For the question 2 for the group 2 and 3, I did this same approach where I have created 2 set of MapReduce. One MapReduce basically run the MapReduce command from raw and store the data in intermediate result, which is useful to run the query on that one. So as you see, the first MapReduce we see basically just creating the intermediate result and storing over here, and rest of all MapReduce is just accepting the query from the user as part of the input, and we run on the output of the first MapReduce that become input for this one, and the output is being stored in their own dedicated format, and we run the queries as part of the asking the query over there. That way we can efficiently run the MapReduce command, and the intermediate result of these ones I'm going to just give you heads up on like how we're going to see like rank of the top 10 carriers of a given airport. So what we did is basically let me copy the file over here. Sorry. Over here. So you see the intermediate output contain the airport name and the carrier, and they're basically the arrival times and the average arrival times, and then we run the queries on those ones, and the output is being finally stored to DynamoDB using my own adapter, which read the file from SDFS to the Dynamo table and do all the type casting based upon the field name over here. And I'm going to give you one sneak peek of one query over here as SDFS output, then we move to the Dynamo table output over here. So if you see into it, this is how the output looks like. Like for one LAX, these are the carriers with the best arrival times over here. So let's move to the basically the Dynamo table output. So for 2.1 over here, I have created everything like you see the best time. So let's run the queries as part of the airport, and we're going to run on the basically BWI. And as you see, these are the best carriers based upon the best arrival time, and you can look into all the values as part of as search as well over here. Output of that everything. For the 2.2, I did exactly same thing where we need to get the top 10 airport based upon their best departure delays, and you see over here we can run the queries especially on one airport as well, and we can run just for example let's run on the MIA, and the MIA will give the output of these ones and their best departure time, like this is the sorted times as well. For 2.4 where we need to get the from airport to airport 2 and their average time, so each queries we run it, and the on intermediate results it was really fast, and this is how it looks like for the CMI to ORD and their average delays over here. For the 3.2 what I did the same thing. I stored the intermediate result, and the key was that from which airport from to, and their flight dates that become a key, and rest of all fields become a basically value like carrier, like which carrier, the flight number and time and all so on and so forth. So at the first, when you provide a query from which in the lag 1, which airport to which airport and which date, we run the query, store the result in the Dynamo table, and over here as you see we have already run the query for the CMI to ORD, and this is what it looks like, and we give the input as which flight date, and based upon that it's give you the flight number, the career departure time, and AM and PM as well on that one. And then we can, for the lag 2 we can do the same thing from ORD to LAX. You see the same as part of the ORD to LAX, and those flight number and the time is being suggested over here. And if you remove that, you will see the output of the all other queries we have run so far. For the 3.1 question where we need to draw the distribution, so I create a table based upon the output of the based upon the rank of the airport, the number of the flights, and the output its graph is following this curve instead of straight line. So that's how I plot and provide my finding as part of my documents. Thank you.